right. Hey, everybody. We are back with more Advent of Code 2022. Last time we got through the first part of the day 11 monkey in the middle question. Did we get through it? No, we didn't get through it. We got through writing the parser for it. And we were in the process of writing up some tests, I think, and then implementing the problem. Right, and I had to drop quickly due to an unforeseen urgency, but everything is good. I am back, and we will continue. So the puzzle today that we started going through last time is basically there are monkeys playing keep away with your stuff. Each one starts with some items that have this worry score. Each time they like inspect it, they do this operation, whatever the operation is, and then they test whether the current score is divisible by some number and change which monkey they throw it to. And in between, so after each monkey inspects the item, we divide by 3 and round down. On a single monkey's turn, it inspects and throws all of the items it's holding, one at a time and in the order listed. The monkeys go in each order, or in each in order of their numbers, and we are looking to simulate how many rounds? 20 rounds. So we want to go through 20 rounds and find the 2 most active monkeys and count the total number of times each monkey inspects items. And then we multiply those together to get the answer. So our basic approach was as follows. So we had, this is problem 7, which isn't what we want. We want problem 11. So we pulled the parser out that we had used before, and then we have 2 structs, the monkey struct and the monkey pool, which is a vec of structs, or a vec of monkeys rather. And the pool knows how to instantiate itself from strings, so we were going through and just finishing implementing the parsing here, where we can consume each monkey from the input file and load it into a monkey pool, and after that we can implement the behavior of the monkeys themselves once we have all their data imported, and find out the answer to our problem. So I think I got interrupted just in doing the last bit of parsing here, where we want to be able to, for each monkey, we're going to consume the starting items, we're going to consume their operation, and then we're going to get the test, the division test that they do. And so when we consume the test, is where we got stopped. And how's this gonna look? So the test says test : divisible by something, so test divisible by, and then we will say this will be the what do we call it? Monkeys test divisor. So then the test divisor will be the rest of the line. That's not the rest of the line. We want to consume line. Trusting we're using consume until white space in other places, and we're using consume line here. I think either one kind of works. Until white space, I guess, is a little more explicit. And that's going to be a string, and then what? Then we say white space parser.consume white space. And next we have if true, throw to monkey. So let's say let true header be expect if true, throw to monkey. Also we should parse this into a U32, and we can expect a valid number to divide by. And then here we will say throw to monkey, and then we'll say let true, what do we call it up here? True destination. Dot consume until white space, and we'll parse this one. This one's going to be a U size because it's going to be the index to an array. Valid monkey destination, false destination. Oh no, we have to let false header, and actually this should probably be its own function. So let's say consume destination parser at need parser, and this will return a U size, and then we will take these, and this will just be like this, and we can just return this. And now this is just let true destination be consume destination parser what do I need a string for here? Why do I ever need S? From string. Yeah, I don't need S for any of this, I don't think. I'm not sure why I had S in there to begin with. This will be nice. Okay. So now this is just consume destination. Oh, and again, you need consume destination, and then white space again. Whoops. This should be here. Okay, consume white space, and then let false destination be self-consumed destination. Ooh, except this is if true. So it'll be destination parser, but then we need to pass in true versus false. And here we will say This has a bool. Which we then say let's see here. What's the nicest way to do this? I guess let header text be if condition, then true, otherwise false. And this becomes, or let's call this condition text. And then this guy can be format all of this, and condition text, and I think this needs to be a reference. Okay, consume to white space, that returns, and then at the end of this we return test divisor, true destination, and false destination. And what's the issue? And missing a semicolon. Okay. Cool. So in principle, this should be doing the parsing. I'm sure there are slight things wrong with this, but we will use the tests to uncover those. What's going on in here? So expect returns a reference, not a result. It does. Unused variable monkey header. Yep, that's fine. Indeed. Okay with that. And then parser needs to be mute. And we're good down to our tests. So what's going on with our tests? Okay, so a couple functions missing. We would like get monkeys. Or sorry, n monkeys should be a function. Pub function n monkeys. Itself should return a usize. It should be self dot monkeys dot length. Right, what else you got for me? Compiler get monkeys, sure, and execute round. This is logical. Do I have a test for parsing already? I do, right? I should. Parses into monkey pool, yeah, okay, good. And actually we want monkey pool, and then get monkeys should be a thing. And it can return a reference to a vector of monkeys, which will just be self.monkeys. Why did we get a double ampersand there? Okay. And what's going on in here? Okay, cool. It can't index into a borrowed vector. That's fine. We just clone it. It's a test. It's fine. And then execute round is not implemented. And I think for the moment, just to check the parser, let's just make that an unimplemented function for now. Okay, so this is all parsing. So then let's say pub function execute round at me itself. Does it return something? No, I don't think so. Oh, we also need to expose an operation function. That's fine. Okay, yeah, execute round doesn't expose anything. And then get monkeys. Oh, and then all of these need what do all of these need? Get items. And likewise. And we'll need to execute rounds as well. And also doesn't return, and we just say 0.n into iter for each. Self.execute round. Okay. All right, those aren't implemented, that's fine. And then the operation was the other thing. So a monkey, apply operation is what we called it. We just didn't change it in the test. Where is it? Oops. Apply operation. Okay. And now we expect some tests to fail, but we can test problem 11. We can go from there. Okay, nice. I love these error messages. They are great. So we are consuming the starting items. We are splitting on commas, and yet we're getting a comma showing up in our parsing. How can that be? Let's say, starting item string be this, and then let's go to the debugger and see where we get to. This is monkey executes round, which isn't really what I want. Parses into monkey pool. Parses into monkey pool. Here we go. Okay. So let's jump one step. So starting item string is optimized away. Nice. And then it bombs out. Does it bomb out? No, it just goes into library functions. No, it panics. Well, that's not ideal. Let's close a couple of these. So I can't inspect this. What you're telling me, because the variable is optimized away. So it's getting inlined. Let's see where our parser got to. What is this? Oh. Oh, that's nice. Even though it, oh, that's really nice. Even though it got optimized away, it tells me what the most recent, what a recent function returned. Slick. Okay, so the problem is that the space is white space, which we don't want. So this needs to be consume line. So it's still failing. Should be able to parse item number in 98. Looks like a reasonable number. Does it have white space at the end of it? Seems plausible that it does. Trim. We should have hit the end of a line, but we didn't, says the parser. It's after consuming this is after consuming all of this stuff. So we consume the line. And does consuming the line end the line? Probably does, right? Yeah, it does. Okay. So we can't say that we expect the end of the line. I would like to say that we expect the end of the line. I mean, we just consumed the line. Like, what is it about? Like, obviously we got to the end of the line. Okay. Parses expected new equals old, but got new equals all. That's fascinating. Really? This is on the test. Example input 11. Ooh, new equals old times old is a thing. So we need to be able to handle new equals old times old. Fun. Although that's not explaining what the issue is here. Why would it be getting this? Okay, let's see. So one thing is I need to remember how to set an environment variable in new shell. Let env. There we go, backtrace. And now let's cargo test test parses into monkey pool. And now consume operation. I see what's happening. There's white space in here. Okay, so we should consume that. Let white space. We'll parser.consume white space. And we probably need to do the same thing at the beginning of consume test. White space. We'll parser.consume white space. Okay. Invalid digit. Okay, again, I think this is I think this is white space. In string consume until white space. We just consumed some white space. Let's trim it. Okay, probably similar story here. Yeah, just anywhere where we're you know, there's probably a slightly nicer way to do this where we like figure out why we're hitting these and we consume them intentionally, and that's what I would do if I were doing something in production. But should have hit the end of the file, but instead we got an E. Well, that doesn't sound right. Okay, it's getting through the whole parser. So one thing we need to do is in consume operation. In fact, how are we not hitting old times old here? So we're gonna need one more operation, which until I hear otherwise, I will call square. And then apply will be self square. Then you do n times n. And what's it, consume operation? And in here we say if n string is trim is old, then let to return equal operation square. Parser.expect end of line. The end of a line. But I don't think that's what was causing this particular failure. We're getting all the way to the end of the file. Which also is a little surprising. I wonder if we're missing... Yeah, I don't think we ever consumed this line, and that's why it wasn't failing. So we get the monkey, and then let's consume white space. Parser.consume white space. Okay. So indeed we get a different thing. We're expecting the end of the file, but we get a Y. That's curious. That is curious. Let's expand this error message. Map error. Self dot consume remaining. So we'll say format expected end of file, but got a slightly better error message. Okay. Should have hit the end of the file, but we got a bunch more. Okay, so one thing is example input is using the wrong kind of line endings. Blame Microsoft for that. Hey, passes. That's what the one thing was. Okay. Sick. So cargo tests problem 11. We expect a lot of failures. I haven't implemented the monkey round yet, but our parser works. Sweet. So So. Now we need to implement the rounds. So in each round, what happens? Okay. Monkeys take turns inspecting and throwing the items. On a single monkey's turn, it inspects and throws all of the items it's holding. One at a time in the order listed. So, for monkey in self.monkeys, let's see here. The monkey needs to inspect. So monkey dot inspect. And I guess we can have that bump a counter. Monkey dot update for relief. This is our worry level getting divided by 3. Match monkey dot test. If it's true, then let's say let destination equal monkey dot get destination. Wait, but the monkey has to do this to each item. It inspects each item in turn. Yeah? Yes. So really we just want let destination worry level. It's not even that. It's because the monkey has all of them. Monkey inspects and throws each one in turn. So yeah, so I guess we could say monkey dot execute round, and then into iter this and have this be a list of item destination level destination, and then we say self.monkeys destination dot push item, and this isn't map, this is a for each. The monkeys have to be mutable, which I'm not sure that, I don't think the bar checker is gonna like what I'm trying to do here, because let's see here. Because each of these monkeys is going to have to be mutable, which means we're going to be executing the round on a mutable monkey, but then we're also mutating the monkeys within this array, which is not going to be safe. But let's put the functions in place first, and then we'll return to that. So monkeys need to execute round. Put function execute round. Mute self, and it returns, let's say, vector of what order did I do it in? Item, which is just a U32. And the destination, which is a U size. And it occurs to me that type aliasing the U sizes into a type called destination would make this a lot clearer. So I'm going to do that. Type destination is usize. Type item worry level is U32. Those are going to be whatever they're going to be. But some of these are going to be different. And monkeys is fine. Starting items should be item worry level. Operation is fine. In principle, that's an item worry level, but I'm not super worried about that. Consume test. I guess this is an item worry level. Kind of just a number though, but these are definitely destinations. And these are definitely, this is definitely a destination. That's fine. Execute rounds, that's a U size, and then this we're gonna fix. And apply operation can be on U sizes, that's fine. Test can be on U sizes, that's fine. Get destination should be a destination. And this should certainly be a item worry level and a destination. Okay, cool. So then the monkey needs to execute the round. So what the monkey is going to do is inspect, which is going to mean that self dot no, it's going to be for item in self dot items. Let new worry level be self dot apply operation on an item, which really should just replace I actually want to pop these off of I want to pop these off the front of the list. So I think I'm actually going to use a vecdq here, or vecdeq, or however you pronounce that. I've heard both. Really? That's imported already? This one's also going to be a vecdeq. And now we can say what? Now we can say while let okay. Is it okay or is it sum? Probably sum. Item b self.items dot pop front. Returns an option. Good. So this is going to pop all the items off and do this to each one of them. And then we will want to get a new worry level. We will want to keep this as I don't need to pop because I'm going to empty the whole thing. That's true. That's a good point. Yeah, that's a good point. All right. So let's not use a vec. And let's just say I don't actually know how it works though. If I reverse this, I guess it's fine. So at the end, we'll just say self.items dot empty flush. Is there no function for? Obviously, I can just set it to a clear. And then this will be in self.items dot reverse. Oh, no, I don't need to reverse anything. How's it going, Gupta? Okay, so we're going to apply the operation, and then how does relief work? Once it's inspected, then we do the relief. So we apply operation, and then we divide by 3 and round down. Which I guess I will do in a separate function. By relief. Item worry level. Whoops. Item worry level. And this is just n over 3 should automatically apply the floor. And this can just be self-apply relief. Whoops. And then we'll need to test the item and get it ready to be returned. And the test happens at the end, yeah. It inspects and throws. Okay. To decide where to throw the item. Next, so then we can say self.test, new worry level, and this returns a bool. Oh, but I can just get destination. Let destination be self dot get destination. And then we push this into the vector. And in fact, I'm just gonna do this in a more functional style and say to return is self.items iter map n, and we will do this stuff. Which I guess we can do as this, and then we don't want get destination worry level though, we want new worry level, get destination worry level. And then we can clear out the items, and then we can return. And what's the issue here? Oh, get destination takes a bool. Okay, fine. So this becomes self.test. Cool. And apply operation. Oh. There we go. Gupta says, am I still working in software dev? I am not at the moment. I have a 5-month-old son, and so I quit my job when he was born, more or less, and I'm taking care of him for a little while. Oops, and my cat needs to get out. Hold, please. What about you? I think you mentioned you're a C++ developer. And what's going on here? Oh, yeah. Fair point. Oops. And the bar checker is not going to like me here. And we know that already. Oh, also, I don't have a function called push, but even if I did, the bar checker is not going to like me, and we're going to fix that in a minute. Okay, let's do push first, though. Oh, wait. monkeys.push. Yeah, but that's an array. So this should be for a given monkey. We want to be able to push a new item on. Could call it push item, but self and item worry level. Doesn't need to return anything. And self.items.push n should be sufficient. Monkeys, self.monkeys. Yeah, and then execute round. This is where the bar checker is going to yell at me. Correct. Okay. Cool. So even if this is mute monkey, I expect the bar checker to yell because, well, for one, this needs to be either into iter or iter mute, which is neither of which is going to work because I'm borrowing it twice. So what's the nice way to deal with this? So the point is going to be that in fact we know that the monkey is not going to throw him to himself, and so we're never updating the same monkey. Which is all well and good, but the bar checker does not care. So, and we can't go and get all of the, we can't go and execute all of the monkeys and then do the throwing because that results in something different. Probably we just do this in a nested loop. I don't see a particularly slicker version than that. So let's just say for item destination in monkey.execute round. VS Code being trying to be helpful and not actually being helpful. So now self.monkey. So now this doesn't have to be mute anymore. Unless it does. No, it still does because it has to execute round. So we have the same problem. maybe we can do this in a while loop, because then we can prove to the borrow checker that we're using different indexes. It's actually kind of tricky. The issue is that we have a vector full of monkeys. We want to mutate separate elements of the vector, which the borrow checker, but the borrow checker doesn't know that they're separate elements necessarily. Like, there's no reason why destination can't be a monkey that we're in the middle of mutating, as far as Rust is concerned. It's interesting. And even if we do this in terms of the indices, it's not going to matter, because Rust won't care that we're mutating both like I and J that aren't equal within self.monkeys. So maybe we do this in 2 passes. We go through monkey, we want to, it's basically like step 1 for the ith monkey, update it. Step 2 for the ith monkey, get the destination, which is an immutable operation, or like which doesn't require mute. Step 3, we have to empty. Step 3, update. The jth monkey with the new item. Step 4, clear the ith monkey. Yeah, I don't like that. So we update it, we clear it out. I don't like that. For the mutable ith monkey, update it and get the destinations. Problem is I'm picking between... I want to be able to randomly access the monkeys and update them. I really don't want to do this using unsafe rest code. I could do that, but I don't want to. I wonder if I can do it by totally replacing the vector every time, which seems really inefficient, but it would work. Alternatively, oh, maybe I can do it by saying let mute new monkeys self.monkeys.clone. I have to clone it once, but then then I can do I in 0 self dot and monkeys. We can let monkey. No, we don't even have to do that. We can say monkey new monkeys. We execute the round and we say new monkeys destination.push. Okay, and the bar checker likes this fine. And then at the end we can say self.monkeys equals new monkeys. And this is working because so what stops me from just saying self.monkeys here and then getting rid of this and self.monkeys? Nothing stops me from doing that. Because now I'm no longer getting a mutable monkey from up here and messing with them. I have a mutable reference to self. I can borrow it mutably once to execute, but then the resulting things are copy, and so I can put those into the iter, and then I can mutably borrow it again to push. Okay. Cool. That was a little bit subtle, but I like the solution that we got to. Let's test. And okay. And we're getting a different answer. We are getting an answer, but it's a different answer than what we expect, which is fine. let's trying to think whether I want to enhance my tests or walk through with the debugger. Which one's failing, by the way? Okay, so the first round is working. So the first round works, and then subsequent rounds aren't getting updated. Interesting. And when we execute the round, we definitely wind up with nothing in items at the end, which is fine. Alright, let's look at this in the debugger, because something seems amiss. So one thing we should check is, we know the monkeys are in good shape. Yeah, or at least we strongly, yes, we know that, we basically know that the monkeys are in good shape. Okay. So there are 4 monkeys. One of them multiplies, one of them adds, one of them squares, one of them adds. Do I believe that that's correct? 4 monkeys multiply by 19. Why does it say, why does the 0th one multiply by 23? Oh, that's the test divisor. Okay. Operation multiply by 19. Yeah, okay. Operation test divisor. Okay, these all look good. There are 4 of them. The test divisors look sane. The squaring is working. Good. Okay. Which is to be expected because the first test is passing. But he has 0 items. Yeah, that's also to be expected. Yeah, we knew that. That's the result of a test. So, like, this guy has 4 items. Does the problem give us additional... it does. So we can add more tests, which I'm going to do. So let's not execute 19 more rounds. Let's pull.execute round, and then we'll do something like this. And let's just copy and paste. I did not copy and paste. Nor did that. See. Shouldn't one of my registers have the thing I copied from my browser in it? wouldn't we think, whoops. Yes, star. Okay. So, okay. And now this needs to be 18 for this to work. And let's see. So we get a failure. Okay, but now we've got a failure between the first and second round. Whoops. Copied the wrong thing. Copied round 3, not round 2. $16, $18, nope. So again, where is my, it's not in star, even though I'm copying it. Okay, now it's in star. I don't totally understand how Vim registers work. Okay. So we get a failure, and the failure is on round 2. So round 2, yeah, should be 695, 10, and so on, and it's still the same thing it originally was, even though I'm calling execute round again. Interesting. Why would that be? Self.endMonkeys. Execute round just returns a vac. So why? How is it managing to run once correctly and then not continue to update? Also, why is the debugger not allowing me to run to the line? Is it returning before it ever... Self.monkeys somehow ending up being 0? Certainly shouldn't be the case. Execute round. Self is optimized away. Okay, there are 4 monkeys. Surely... Self.monkey I. Certainly exists. Iter is 1 through 4, but that's only because I popped one already. Self monkeys 0. So why are we not ever hitting this breakpoint? I feel like this is a VS Code thing. Where it like really does not handle these nested functions very well. Mute pointer, mute pointer, mute pointer, blah blah blah. If I just step over this, what happens? Still tries to go to the mute pointer. I want to hit one of these breakpoints. But it's not gonna let me. It just exits. It forces me to set the breakpoints before. I guess it's forcing me to set the breakpoints. So I can set it with an expression. Seems kludgy. Okay, one thing I can test. I can't really test it that way. So what would an expression be that's not going to trigger before then? Like self.monkeys items is this. It's probably going to trigger other times. Yeah, and I'm going to have to click this. I guess I can work out how many times this triggers. Doesn't seem fantastic either. Okay, I guess I can just click play that many times. Okay, go away. Let's just do that. So now items is length 4, 20, and so on. Yes. So now we expect to apply the operation and apply relief. Is the operation the correct thing? Sure seems like it. Okay. So to return is now some totally different number. This seems correct. I mean, I don't know if it's correct, but it certainly makes sense. Item 145, I is 0. Seems reasonable. Okay, there's something stupid is going on. My spidey sense is tingling. Oh god. Yep, something stupid is going on. This monkeys is what we... this monkeys is not the same monkeys that's in the pool. It gets cloned. We need this in every line. That will do it every time. Okay. Okay. Making progress. So now we are on round 3, and we're saying, yeah, this is wrong. We want this. Okay. And then here, okay, so we've executed 3 rounds, so this has to be 17. And there we go, we pass. Okay, sweet. So we're able to execute our rounds, and so now we just need to get the resulting, like the answer to the question, which involves counting how many times the monkeys each inspect items. So we probably want to add a counter to the monkeys. And let's do that by saying what? Inspection count, view size, and this becomes inspection count 0. And now anytime that we inspect, which is this, we need to increment. So we can just say to return iter for each. Self.increment. Well, I guess let's change this actually. Let's change this to inspect. operation, we will say pub function inspect, add self in, and this will self dot inspection counts will get incremented, and self dot apply operation. Oh, it has to be mute then. That should be fine. Now what's the problem? Debugger doesn't want to tell me what the problem is. Okay, but now I'm borrowing twice. That is true. All right. Let's not do it like that. Let's just say to return iter for each self dot inspection count plus equals 1. And now what's the problem? Ugh, it doesn't like it, thinks I'm borrowing. So why do you think I'm borrowing now? Oh, it just needs to know the type annotation. Okay, and then what we want to be able to get the inspection counts. And then in our pool, we want to be able to get the 2 highest monkeys inspection counts. Get inspection counts, and we'll just make this a vec of view size. This will just be self.monkeys dot iter dot map and dot get inspection count. And then in our function, this will be the pool, the monkey pool input, nope, from string, input, pool dot x, it's got to be mutable, pool dot execute rounds 20, let mute inspection counts be pool dot get inspection counts, inspection counts dot sort, that will sort ascending, we need it to sort descending. And And then we want inspection counts 0 times inspection counts 1, I believe. And what's the issue here? Why am I not getting... VS Code is failing me here a little bit. Oh, I have to collect that. And it probably needs to know what type it is. Okay. That's definitely not the most efficient way to do this, because sorting and reversing is not efficient, but it's not going to be a big deal. Okay. The parser's failing. Why is the parser failing? That's unexpected. Okay, so it's getting through the example. Oh no. Yeah, it is. It's getting through the example. The example's correct. But then the parser is failing on... Should have hit the end of the file, expected the end of the file, but got right. It's this stupid thing. Okay. And that looks like a proper answer. 64032. That's a satisfying number. It has 2 powers of 2 in it. All right, let's take a look. 64032. Submit. Boom. Okay, that was Monkeys Part 1. Monkeys Part 2. You're worried you might not ever get your items back. So worried, in fact, that your relief that a monkey's inspection didn't damage an item no longer causes your worry level to be divided by 3. Unfortunately, that relief was all that was keeping your worry levels from reaching ridiculous levels. You need to find another way to keep your worry levels manageable. At this rate, you might be putting up with these monkeys for a very long time, possibly 10,000 rounds. With these new rules, you can still figure out the monkey business after 10,000 rounds using the same example above. After 10,000 rounds, the 2 most active monkeys inspected items that many times. Multiplying these together, the level of monkey business is bigger. Worry levels are no longer divided by 3. You'll need to find another way to keep your worry levels manageable. Starting again from the initial state of the puzzle input. What is it after 10,000 rounds? Okay, so this is the first one that's really testing how efficient our code is. So that's exciting. So we need to add in a way to choose whether or not we do things with relief. So what to say here? I guess execute round. I guess we just pass it in. So we say with relief is a bool, and we pass it into here, and we do the same thing here, and we pass it in here, and we do the same thing here. And let's say let maybe apply relief be a function that takes a number, an item worry level, and if with relief, then self-apply relief. Otherwise, just return n. Probably need brackets around this. Oops. Okay. And this becomes maybe apply relief. So that should conditionally apply relief, and then we'll need to update our tests. So this is do apply relief, do apply relief, do apply relief, and do apply relief. Okay. Okay, we get a failure, but it's because I never put the answer in for this. This was 64032. Okay, and now we get one failure. Cool. And so now solving problem 11A is going to amount to executing 10,000 times with relief false. And then getting the top two still? Yes, getting the top two still. Okay. Let's see how long this takes to run. Not long. Probably because it didn't hit. Oh, it attempted to multiply with overflow. Lovely. Okay. Well, couple things. First, let's actually put in the example error here. Separate this out a little bit. And the answer that we expect is this. Not that. Really need to figure out why our registers aren't doing the thing that I expect them to do. Still not right. Manually paste. It wasn't a star register. I gotta sort that out. Okay. So now does this, presumably this still multiplication overflows. Oh, solve problem 11B. Attempts to multiply with overflow. Perhaps not shocking. So what is the max of a U32? It's 4 billion something or other. So what I want to do is just replace all these U32s with U64s, which is one way to do it. Is there something better? Possibly, but let's try it. Do I have other U32s? I do, right? I definitely do. Yeah, U32. Is it this? U32 should be replaced by U64 globally. There we go. Still compiling. Okay. It runs, but it still overflows. Really? Okay. Well, I imagine this is the point of the puzzle. So I have 20 minutes before I have to sign off, so what to do? So obviously one thing to do would be to use an even larger number type or implement that myself, but that sounds like it's probably not the answer. More likely there's something clever here. So let's think. So, counting the number of inspections is very different from, like, knowing whether our worry goes crazy. In the sense that all we care about is divisibility. And so if we have some way to keep the numbers small while maintaining their divisibility properties, then we won't have a problem with multiplication overflow, probably. So we can work modulo something. Is probably the answer here. So if all the monkeys had the same divisor, we would just work modulo that, and we would be fine. We don't have that. Instead, though, we can work modulo the product of all of the divisors, which is plausibly still a big number. It's not that big. I think this might work, because famously there is a algebraic ring modulo I guess, is it an algebraic ring? If we work modulo the product of the numbers, the point is that that modulo respects addition and multiplication. That's not always true, though. That's only true if it's modulo prime, which it's not going to be. Certainly it'll still respect addition. Okay, so we could instead consider the worry levels to be modulo each. We could keep the worry level around. We could just keep its modulus with respect to each divisor. And if each divisor is prime, which is each divisor prime? 23, 19, 13, and 17 in the example. And what is it in the input? 23, 19, 13. Oh, that's the example. What is it in the input? 11, 5, 19, 13, 7, 17, 2, and 3. So those are all prime. Okay, so I think that's going to be the solution. So let's not have these be... where's my problem? Let's not have these be U32 or U64s, because I don't think we're going to need it. But we will change... Oh, and this is nice, actually, that we used item worry level for this. Because now we can get rid of item worry level. And actually, I'm going to go ahead and commit this first. Solve problem. 11A. Just in case I decide I'm bungling this and want to revert. And then let's get rid of item worry level. And instead, what we'll do is have a struct. And the struct will derive all of the usual things. We don't need default. We can have hash. It will be a struct of a vector of moduluses. We'll call this worry, item worry level. Levels, and this will be a vec of U32s and moduluses, modula, radius, radii, moduli, and this will be a vec of U32s. And then the idea is going to be that function new. And if we just want to put in the levels, that's fine. We'll just assert that levels.length and moduli.length are the same. But then, more commonly, we will instantiate this by saying from n. And this will be a single U32 and then the moduli. And the point here is that we will let levels be moduli.iter.map and mod m. And now self-new levels moduli. So now we've taken our worry level, which maybe I'll just say from, that's fine. From n is fine. We've taken our worry level and we've broken it up into worry levels mod the moduli. And now we can do arithmetic on those. So let's impl add for item worry level. And this is usually where GitHub Copilot is helpful because it fills these in for me and I never remember them. Rust impl add. That's the one. Okay. Impl add. Whoops. I pulled one too many things in. I'll put self, other, and then what to do here, we're going to say and I don't want it to be, I'll put self as fine, but it's U32 that I want to be able to add. And so this is just going to be what? This is going to be self dot levels iter modulus moduli iter map. We can call this n, and this will be I guess I want to zip this with self dot levels, and then the map will be from mn, and we'll say oh, we already have an n. Okay, fine, let's call this other. And then we'll say n plus other modulo m. And then this will be the new levels. And we'll say self new levels other self dot moduli. Okay, and maybe it doesn't like me borrowing something there, and that's fine. We'll fix it when the compiler yells. Okay, so now we can add. We also want to be able to multiply, which is going to be the same thing. It's mul, isn't it? And all that we will do that's different is this will be multiplication. And then, okay, that lets me do the things I want to do. And essentially item worry level here is a direct product of rings. Of algebraic rings of modulo P. This can't be copy, which is fine. And okay, what's the issue here? Add is an incompatible type. I'm not allowed to add a different type. That's not right. Oh, it's impl add u32 and multiply u32. Okay, and now new levels. I need to collect. And here also I will need to collect. Okay. And what else we got? Okay, and so now everything's yelling at me because item worry level can't be divided by 3 anymore. Ugh. That is fair, but annoying. So division. Okay, so it's actually they've done us a favor kind of by getting rid of the notion of relief, except that it messes up my nice types, because division division is defined on a ring. There's something called a division ring, I think. But yeah, I'm pretty sure division is defined here. But I don't want to implement it. But that means that my monkeys need to be implemented differently depending on whether I'm solving problem A or problem B. Which I don't really want to do, but I guess I can. So one slightly kludgy thing I could do is make it so that the whether or not you're applying relief is instead a function of how item worry level is defined, whether it's defined as a integer or as a or on this ring, which happens to work in this case. So I might end up doing that. I think I'm going to call it here because I need to go in 3 minutes anyway, and this is going to be a little bit of a refactor, and it'll be a decent place to jump into next time. So I'm going to call it here. I'll be back tomorrow at 1 p.m. Eastern time. Hope everybody had a good day and is enjoying Advent of Code, and I will see you tomorrow. See if there's anybody to raid. Hey, Mr. Halsey's here. Let's raid Mr. Halsey. All right. Take care, everybody.